On Unit 6, Lesson 3 of Trigonometry, calculating the length of a side in a right triangle. The warm-up here, as we just discovered, that's not really a warm-up. It's just more like reviewing the forms of the Pythagorean theorem. Let me just explain this so that we understand. The two short sides squared add up equal the long side squared. And then when you're finding a short side, it's the long side minus that opposite side. So a squared is c minus b squared. B squared is c squared minus a squared. Okay, that's the different types of forms you can use to use Pythagorean theorem. Okay, so in doing so, let's try these ones here. So this one we're missing the long side. So this would be an example of a squared plus b squared equals c squared. So 2.5 squared plus 3.7 squared equals x squared. Okay, can somebody calculate that for me? What's 2.5 squared plus 3.7 squared? What is it? 4.5? These two added up? Yeah, so this is 4.5?
No, that is 2.5 is 6.25.
You guys are confusing me. 6.25, and what's this one? 19 point. Okay, and then you square rooted, and that's how you got the 4.4? Gotcha. Okay, couple things. Okay, I kind of did something today in Math 9 that was pretty fun, I thought. A lot of these things you have to have some logical reasoning. Logical reasoning would be this. I got 4.4 for my answer. Does that answer make logical sense? Is it bigger than the other two sides? Yeah. Okay, so we feel good about it. That's the first thing you should check. If your hypotenuse is smaller than a leg, you messed up. Okay, you have to make sure we understand that. This should be the longest side every time. Okay, so we come over here. This time they gave us the longest side. So we're going to go longest side squared minus shorter side squared gives me the other shortest side. Okay, so this would be 122 squared minus 120 squared equals, we'll call this C. Well, you guys won't want C. C is technically the hypotenuse. Let's just use A. Questions on that setup? Yeah. A squared. Okay, what is that? Like, what are these subtracted? 14,484. 800. That's right. And then what are they subtracted? 484. Okay.
I'm so confused.
Perfect.
I got 484. For the square, not.
Okay. So you got one of these numbers are wrong, Luke? So then what's wrong? Like you didn't get 484? It's 484.
I don't know. I don't know. I got the same answer, but
Okay. Well, 22 is good. Okay. 22 is good. Does that one make logical sense? Yeah, 22 is way smaller than the other ones. Okay. That's good. Definitely looks way smaller, right? Okay, perfect. Let's keep going here. Okay, so using trig ratios to calculate the length of the side. So now we're using trig ratios to help us find missing sides, okay, rather than the Pythagorean theorem. Okay. So what you have to remember for your trig ratios, guys, remember sine is opposite over hypotenuse. So cosine, adjacent over hypotenuse, tangent, opposite over adjacent, TOA. Okay. Get that acronym down. So that's pretty much just notes. That's something that when you get your test, you can write on the top. So I got my acronym there. You can use that for a reference. Okay. All right. So in the right triangle ABC, we are given the length of one side and the measure of the acute angle. So right now, why can't I use Pythagorean theorem? I only have one side. So trig ratios help us when we have an angle and a side. Okay, and we really have, how many angles do we really have? How many angles do we really have? Three. If you have two, you have three in triangles, right? If you have two, you have three. Because if you have two, we know what the third is, because it's the last part of 180. Okay, so keep that in mind with your triangle skills. Okay, perfect. All right, so In the right triangle ABC, we are given the length of one side and the measure of an acute angle. The procedure for determining the length of the side marked X is stated below or started below. Okay. The given side 14.2 is the hypotenuse. The other side determined is we're trying to get the X side here is opposite the given angle. So we use, so this is what we're trying to figure out. What ratio are we using? This is opposite over, nope, hypotenuse. Which one's OH? Sine. So, sine. Okay. What are we solving for here? X. So keep that in mind. It's X divided by something. How do I get rid of that something? Multiplied. That's why they multiplied here. Okay. Whoops. They actually have sine there. Because 14.2, that's times sine 52, equals X. So we just multiplied the 14.2 to both sides. Please put that in your calculator now. Make sure your calculator's in degree mode. In your calculator, you're putting 14.2 sine 52. $11.2. Okay. How do we feel about 11.2? Smaller than the hypotenuse, right? Looks definitely bigger than that side. Okay. If we do our math here, this is going to be 38. So we're expecting this side to be the what? Correct. It is adjacent, but I meant in terms of size. Smallest. Okay. This is the biggest. That's the second biggest. That's the smallest. Okay. 90 makes that guy. 52 makes that guy. 38 makes that guy. Okay. It's kind of hard in the video if I'm not actually drawing it. 38 makes that one. 52 makes that one. 90 makes that one. Okay. All right. So any questions on that? That right there is a basic overview of using trig ratios to find missing sides. Okay. Let's keep going here. A ladder. Oh, did I get it all? Am I going too fast? Let me know. Got it? Okay, sorry. A ladder 4.5 meters long just reaches the top of the wall. The angle between the ladder and the ground is 65 degrees. Make a rough sketch to determine the distance between the bottom of the ladder and the bottom of the wall. So we have our wall. The ladder goes right to the top. Okay, we're trying to figure out this distance, and we are told that it's 65 here, and the ladder's 4.5 meters. That's the picture. We comfortable with that? Okay. Ridge, just take a shot. Again, I'm okay if we get it wrong. What ratio would you use here, you think, to find X? So right here, oh, sorry, that's your 90.
4.5.
Yeah, which sine, cosine, or tangent, you think?
Sine.
Yep, that's correct. Okay, it's sine. Okay, because here's the angle. Now here's the thing, guys. Especially if you don't get these right off the bat, what side do we have? What is this side? Hypotenuse. So which ratio is out the window? We can't use tangent, right? Tangent is opposite of adjacent. Tangent doesn't have hypotenuse. So we know it's cosine or sine. So the only thing you have to ask yourself now, this angle, do we have the adjacent side or the opposite side we're trying to find? The opposite. So it's so again. It is sine. Luke, your question?
I was just wondering why the 65 degrees isn't like, it says like the angle between the ladder and the ground.
Oh, okay. So, you're right. I'm wrong. Okay, but we were so, hey, for my drawing, Ridge, you're right. It was 60. It was sine. Yeah, I had 65 in the wrong spot. Sorry, my apologies. So it's cosine. Okay, but we were right in how we had drawn, so it's just a little extra practice. Okay, sorry about that. So yeah, now it's adjacent because it's right next to. So we're going to use cosine. Again, apology for the mix-up. Cosine of 65 is equivalent to x over 4.5. That's the ratio. We're going to times 4.5 to both sides. like so. So we just move the 4.5 to the other side of multiplication. What is that calculation? Yeah, Lauren, do you have a question? X. Here? Here's the angle. Yeah. 'Cause it's from the ground, so I had in the wrong spot. Yeah. You good? Okay. So you said that the x side is, you said what? 1 point what? 1.9. Now this, does that make sense? To me it does, because this is the smallest side. How do I know that? Well, that's 65. This has to be 25. 25 makes this side. So this is the smallest side, this will be the medium side, and then of course that's the largest side. So again, that's using the logical reasoning. Is your answer okay? Yeah, I expect it to be somewhat small. Okay, because it comes from the smallest angle. Okay, if you're confused what I'm saying about that, remember, the angles of the triangles, that size of angle creates the side that it projects to. So this angle creates that side. That's what makes this how big it is. Same thing here, 25. That makes how big that is. As I fluctuate that, my side gets bigger, right? Okay, so it's understanding that angles create sides. Okay, perfect. Okay, determine the height of the wall. So now we're doing the height of the wall. Okay, so we're just going to do the same. I'll just kind of keep it frozen here. So now we are doing sine. So we want to find this now. Okay, so we're going to go sine of 65 equals x, the other x, or m if you want to call it middle, over 4.5. Okay, so then we times 4.5 to both sides. Okay, somebody calculate that for me. What do we get? What's that? 4.1? Ooh, it's really close to the hypotenuse. Okay, x equals 4.1. Still makes sense. It's smaller than the hypotenuse. We're good. Wants us to use Pythagorean theorem to go ahead and verify. Okay, did we round the 1.9? Okay, so it's going to be a little bit off, but if we do it, if we go, we're trying to find the middle, this one, use the Pythagorean theorem, it'd be 4.5 squared minus 1.9 squared equals that other side squared. We're just verifying this with Pythagorean theorem since we have two of the three sides. So go ahead and calculate that for me. Let me get my calculator here so we can do this together. So for 4.5 squared plus, minus 1.9 squared, you should get 16.64. And then we're going to square root it. You're going to get 4.1. 4.07, I'll round to 4.1 so that we're the same. Okay, so we get it again. Just proving that it works using stuff you already know. Question concerns yet? Okay, I think trig, like once you kind of get the ratios down, this work's actually not that hard. Okay, all right, so let's see here. We got last page. We'll take a break and then we'll hit up the next one. Okay, in all previous work, the side which had to be determined was the numerator, the trigonomic ratio of the trigonomic ratio, sorry. Complete the work below to determine the length of the side which appears in the denominator of the ratio. So we're going to do this work here. So which trig identity is this, or ratio? No. What's A? Yeah, A is my hypotenuse, right? So tangent is out the window. Okay, so that's hypotenuse. It's adjacent over hypotenuse, and as Luke said, that's cosine. This is a cosine problem. Okay, so we'll do this the first time, but if you remember back to, this is a random example, it's not part of the problem. Back to Math 9, we did these. If you have 3 over x equals 4, essentially what happens is what? Who remembers in Math 9? Yeah, Jose? Right, you times the x, but essentially what happens is the 4 and the x switch spots. So if I times the x over, what am I going to do next? Divide the 4. See, they switch spots there. So if you want to kind of, not a shortcut, but just know that's what happens, you don't have to show those steps every time. Okay, so what I'm telling you here is essentially the cosine 64 goes here, the a goes there. They switch spots. Okay, so that's kind of like that's what's going to happen. Okay, I don't want you to think it's a trick. All right, so here we go. So cos is here. See, they times the a over, so that the a is off the bottom. We don't want a on the bottom. And then we divide both sides by cos 64. And so then we go 7.9 divided by cos 64. That'll be my a. So what is that? 18. Does that make sense? Yeah, 18 is definitely bigger, right? So we feel good about it. Yes? Yeah, we use tan. We'd use tan if, like, for example, if I said I wanted you to find the opposite side. Yeah. Just haven't used it yet. Okay. Determine a 1 decimal place. The length of the hypotenuse of a triangle PQR, in which PQR is 90, angle PRQ is 28, and PQ is 15.6. So the first thing, a lot of information there. We want to go and draw our triangle. Okay. This might not be to scale because I just made this one randomly. All right, so we know we have PQR because it says PQR is 90. Angle PRQ, so that'd be here, is 28. And then PQ is 15.6. What's the hypotenuse? Okay, I'm going to pause the video. I want you to do this one on your own and see if you can get it. Okay, so this one, I hope that you saw that that is opposite. We're trying to find a hypotenuse, so OH, you should be using so. Sine 28 equals opposite 15.6 over what we don't know, hypotenuse. Again, they're making you practice some of the variables on the bottom, so like I told you, essentially these switch spots. So it's going to be A equals 15.6 over sine of 28. What do we get for A? 23 point what? 33. Okay, so I'm going to go 23, 1 decimal place, 0.3. Oh, 33.3. It is? Because 33.23? Okay, so that? You guys are confusing me. 33.2. All right. Okay, last one. We'll take a quick break and then we'll hit up lesson 5 or 4. Okay, use trigonometric ratios to determine, stay with me, determine AB and AC. So we're finding 2 values here. Okay, so we want to find, let's find AB first. So we're trying to find this guy. Okay, what do we have here? So, yeah, we're going to use tan. Hot dog, yeah. Opposite over adjacent. So for tan, you're going to have tan 71 equals, we'll call it AB over 147. So we go 147 times tan 71 equals AB. What's that calculation? 147 times tan 71. 426.9. Okay. Does that seem reasonable? Yeah, because the reason it seems reasonable is because 71 is a pretty big angle. That means this guy's only 19. So yeah, that's the smallest side by a lot. Okay, so that makes sense that this one's that much bigger, and we expect this to be even bigger. Okay, so let's do that again. Now we're doing adjacent to hypotenuse. Cosine. Okay, 147 over h, or CA if you want, or AC. I'll put h for hypotenuse. Again, variables on the bottom, the situation where they essentially switch spots. H equals 147 over cos 71. Okay, somebody calculate that for me. 451. Okay, we're good. That's all for lesson 3.